Hey, what's going on, guys? Let's do this problem right here. This question is asking approximate definite integral 0 to 1 x cos x cubed dx to within 3 decimal places. So here we are going to use alternating series estimation theorem. It says that error is at most the absolute value of the first neglected value, right? So whenever they are saying 3 decimal places, what we do is first we convert this alternating series into power series pattern, right? Then what we do, we integrate that one to integrate some parts and find the value that gives us 3 zeros, right? And we neglect this value, whatever the x, like some number, right? 3 zeros and some number. We neglect this part and add the values before that, and that's how we derive the final answer. And let's see how we can do this. So first of all, we have to convert this definite integral to power series pattern. But in order to do that, we can use this one. You can memorize this one. This is always going to be, this is like generic pattern to convert a cos function. Now we are going to use this one to convert this one into this pattern. Now let's go ahead and do this. So here we have cos x cubed, right? So let's go ahead and plug cos x cubed, and that's going from 0 to infinity. Right, 0 to infinity, and then we have negative 1 power n, so negative 1 power n, x power 2n, now we are going to have x power 6n because we are going to use x cubed, right? So this is going to be x power 6n. In the denominator we are going to have 2n factorial. Now this is for cos x cubed, but we have a x value before that. So what we do is we put that one right here, x cos x cubed, and we put this one in front of this, x sigma n is equal to 0 to infinity negative 1 power n, x power 6n over 2n factorial. Now if you notice, we have x power 6n right here. What happens if you multiply x power 6n and x? That's going to give you x power 6n plus 1, right? Because when you multiply, powers will add. So here we can do that thing right here. We can bring this x to this side and add with this one. So that's going to give us, maybe I use a different color, x n is equal to 0 to infinity negative 1 power n, x power 6n plus 1 over 2n factorial. So now we have converted this definite integral into power series pattern. Now we have to integrate this one, right? Now let's go ahead and do the integration. So here we are going to have integration of x cos x cubed is same as integrating this power series. Now after I bring this x right here, this one doesn't exist here anymore. Now let's go ahead and do the integration. So integrating power series is very simple because we are going to integrate only this part right here, right? Others will remain the same. Now let's go ahead and do the integration. This is going to be negative 1 power n, x power 6n plus 1 over 2n factorial. Right. Now if we integrate this one, what we are going to do is we are going to add one more to this x power and divide by the same power. Now let's go ahead and write that one. So this is going to be negative 1 power n, x power 6n plus 2 over 6n plus 2, 2n factorial. So this is going to be the integration of that one. Now if this is going from 0 to 1, right? We shouldn't forget that. going from 0 to 1. Now this is going from 0 to 1. And if we apply 1, this is going to be itself, it doesn't change. Now if we apply 0 for x value, that's just going to be 0, right? Because if x is 0, everything is 0. Now let's apply 1. So this is going to be negative 1 power n 1 power 6n plus 2 over 6n plus 2 2n factorial minus 0, right? And also I forgot to put sigma in front of it. We had to have a sigma in front of it. And it's equal to 0 to infinity integral 0 to 1. Now after we integrate, still we have this sigma. That's going to be sigma n is equal to 0 to infinity, and again at the end we are having sigma. Right, now we have everything. Now let's go ahead and do this one. So what we have to do is let's take some terms. For example, here we need terms until this one is going to have 3 zeros, because we have to neglect the value and add the values before that. Now let's go ahead and find it. So if I do this, 1 power anything is just going to be 1. So we can eliminate this part from here. So this is, we can write this one without this one, right? So that will make everything easier. So let's write this one. Sigma n is equal to 0 to infinity negative 1 power n over 6n plus 2 times 2n factorial. N factorial. Now this is the one we are end up with. Now let's go ahead and do some calculations. So in order to do that, what we have to erase some of the part. We need space, right? Let's erase this one. Now we have to find the value we get until 30. So let's go ahead and plug some values. Let's start from 1. If you plug 1 for n value, it's going from 0, right? So first term is going to be 0. If you plug 0, this is going to be 1 over 2, right? 1 over 2. The first term is going to be 1 over 2. And then the second term is going to be, if you add 1 for this one, this is going to be negative 1 over 6 times negative 1, that's going to be negative 6 plus 2, 6 times negative 1, negative 6 plus 2 is going to be negative 4. Actually it's 1, not negative 1. 6 times 1 is going to be 6 plus 2, 8, right? 8 times 2 factorial. So we are going, the second term is going to be 1 over 8 times 2 factorial. 2 factorial is same as 2. You can write 2 or 2 factorial. 2 factorial. Now the third term is going to be, if you square this one, that's going to be positive. And then 6 times 2 is going to be 12, 12 plus 2, 14, 14 times 4 factorial. So 14 times 4 factorial. And then the next term is going to be, if you add 3 to this one, this is going to be negative 1 again. And then we are going to have 6 times 4, we are starting here. So now we are going for 3, right? 6 times 3, 18 plus 2, 20. So this is going to be 20 times 6 factorial. Now we have all the values. Now let's go ahead and see which one gives us 3 zeros. Now if this is going to be 0.5 and this is 1 over 16, and this one, if you calculate this one, you will get around 0.0029. So we can't neglect this one. We want one more zero to come, right? So in order to exclude. Now if you calculate this one, this is going to be 0.00007. Now we have got a value that is three zeros. We have 3 zeros already, and actually this is correct to 4 decimal places because we have 4 zeros, but we only need 3 zeros because the question is asking approximate within 3 decimal places. So we only need 3 zero, but if it more than that, it doesn't matter. We are just going to neglect this value. If it's 3 or more, we just neglect this one, and then the addition of this one is going to be the approximation. Addition of these 3. Now if you go ahead and add them together, that's going to give you, so let's show it. So this is going to be approximately 1 over 2 minus 1 over 2 factorial is 2, so this is going to be 1 over 16, right? Plus 1 over 14 times 4 factorial. If you expand this one and multiply, that's going to give you 1 over 336. And if you calculate this value, this is going to be 0.440. And that's going to be the final answer. That's going to be the approximation of this definite integral to within 3 decimal places. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.